I just said, Zach, what is your biggest technological regret? And he said,
implementing the Ash internals originally as a graph solver instead of just regular code, like straight, iterative code. Yeah. Was the bad idea.
Graph solver was a bad idea. So there you go. Biggest regret. And with that, give a warm welcome to Zach Daniel.
All right, we got a lot to get through. We're going to get started. Ash Framework is a resource-oriented declarative design application framework. The application framework part is really an important aspect there. It's not a web framework. It's not an ORM or a data wrapper. It's designed for building an application layer. So Ash as a project is growing very quickly. Since I haven't updated this slide, it's probably a lot more than that. But since we moved to Elixir Forum, we've got a lot more folks that have been sharing and sort of participating. We were sort of locked up in our Discord server before, and people thought that the project was dead when we had like hundreds of people talking, but Discord is a bit of a walled garden. So Elixir Forum was a very good choice. We've also got a Prog book, Pragmatic Programmer's book, coming soon. Rebecca Lee is doing really amazing work. Her writing style is really amazing, and I am helping. So this book is a very exciting project, and I think a lot of people are looking forward to it. So the story of a function. So this is a baby function, right? This is extremely simple. It's beautiful. And you look at this, you know exactly what it's doing. It's very easy to understand. You're not confused. This is a toddler function. It is also simple, but I would say that it is heading towards a troubled childhood. All right, this is an adolescent function. It's unpleasant, it's a handful, and it talks back to its parents. And what I mean by that is that this function knows a lot of things. This function has a lot of opinions about the way that you communicate with it. So for instance, if you want stats, you have to say stats true. If you want to sort, you don't say sort true, you say sort top. You don't tell it how you want to sort, right? It's all of this little embedded knowledge peppered throughout this function. Okay, this is a grown-up function. It's cleaned itself up. I would argue, however, that its potential has been wasted. And there are millions of functions like this out there. These are what our applications are constructed of. If you're building Elixir web applications, you have hundreds of these where to allow data access and to manage mutations to your domain. It's all of these context functions that basically have sort of shared functionality abstracted out into functions that you call. So the truth is, this isn't bad. Like if I went, I'm a consultant, I look at apps all the time. And if I went in and I was like, here's what do I need to look at, what do I need to debug, I wouldn't go, oh no, what have they done, right? This is okay. I just think that we can do better. So I'm going to take an aside to talk about imperative versus declarative. And when I say imperative, I'm really talking about in contrast to declarative. So in an imperative paradigm, you might be working primarily with code. In a declarative paradigm, you're working primarily with data. You want to represent as much of the things that you do as data as possible. In imperative paradigms, you might be working with instructions, whereas in declarative paradigms, you're trying to state the end result. So for example, you might tell your child to pick up their toys, put their laundry in the hamper, and make the bed. In a declarative paradigm, you'd say, your room better be clean when I get home or there will be hell to pay. Now, an important distinction here is that this only works if your kid knows how to clean their room. If you never taught them that, you can't just say, clean your room. It doesn't work that way, right? So declarative design requires smart tools, and that's a very important other side of the coin when we talk about declarative design. You can't just say, write your code declaratively, because you're missing the other half of that, of build a smart tool that you can interact with declaratively. So this is an example. I think it's really important to understand that imperative and declarative are relative terms, and their meanings have changed over time, and usually it's about how much detail do I have to give the computer versus 5 years ago or something like that. And you can see an example here. This was the imperative declarative debate not that long ago, and it still kind of is, which is in this JavaScript example, we're not saying, and look, there's a for each in JavaScript, this is an example, but we're telling it how to go from the beginning to the end of the list, right? We're saying you start at 0, then you get the thing at that index, and then you increment a variable, and you get the next thing, right? That's imperative. Whereas in this Elixir example, we're saying enum.map. We don't tell it how to go from the beginning to the end of the list and do something for it. Like, we just tell it, do that, and the implementation is figured out. The enumerable protocol handles that work for us. So, and 20 years ago, it would have been a different discussion of like, am I handwriting data access code, or am I writing SQL, or am I writing whatever, right? So this is a discussion that is essentially changed over time and is relative to what we do on a daily basis. So this is an example of what you might see in actual Elixir code. You might see some sort of function designed to authorize access in some operation that you have, right? So in this case, we're going to say, hey, if the user's deactivated, then it's forbidden. You can't do this. If they're a super admin, then yeah, you can do whatever you want. And if they're active, then we're going to maybe filter an ecto query and say, like, okay, show them the published stuff. So these look really similar when you look at the declarative example. It's the same workflow, right? We say forbid if the user's deactivated, authorize if they're a super admin, otherwise filter by published equals true. But there's a big difference between these two in practice, although they look similar, which is that policies in this example are data. So that's that. It's a data structure that we're going to dispatch to a tool that can do basically smarter things than would be reasonable for us to handwrite. At some point, it gets compiled to that, and that's not a joke. That actually is what we eventually turn that into before we pass it to what's called a satisfiability solver that is designed for solving Boolean expressions, right? So the point here is you don't have to really know how that works. The tool knows how that works, and you tell the tool what the rules are, and it figures it out. So that becomes that, and there's no way that I could have turned this example on the left into something that can be given to a sat solver. It's not possible. So this is, again, that example of data over code. So I want to talk about artificial constraints. Imperative code imposes artificial constraints, essentially a problem of being too specific when telling the computer what we want it to do. So this class of problem exists all over the place, and once you see it, you can't unsee it. You start thinking of like, if I had been less specific, it would have been able to do a smarter thing here, but instead, I give it a very specific set of instructions, and so it can only do this very specific set of instructions. So let's take a look at some examples. Let's talk about order matters, right? So this is a really simple example. We've got some code in here that's going to compute some fields. We get a tweet, and then we add a computed field, and then we add another computed field. But in this example, what's hidden from you is that add some computed field 2 depends on the field we computed in the first one. If you were to swap those two lines, it would stop working. You'd get weird, nil dot whatever isn't a function, all that sort of stuff. And this is an example of it doesn't really have to be that way. There are ways to define calculations and calculated fields such that they figure out their own dependencies. But because we wrote it this way, it is true. Simple or optimized, pick one. This is something that this is every engineer who's been coding for a couple weeks starts to understand that you start making trade-offs for simplicity's sake. And that's the right trade-off to make. If you have to make something mega complicated just to make it performant, my point is that simplicity has value over complexity when you have to choose. So let's take this simple example here where we have a query that we're going to run, and we want to filter where it's for active users. So the tweets for users that are currently active. And we also want to only show it where it's from friends of this current user. The problem here is that we're actually joining to users twice. When we combine these, for active users joins to users, and from friends of joins to users. And the truth is, who cares, right? Like in a normal application, you're not going to bother factoring these kinds of things out because there's an index on user ID. It's not a big deal. However, let's assume that you got to a point where you did need to optimize this. There's enough data, you can't use an index, whatever it is. You have to optimize this. So these are the two joins. So this is what it looks like to optimize it. It's like a way more complicated. And if somebody made a pull request to a code base that I was in charge of, I would reject this pull request unless they could really back up the fact that this joining users twice was a problem. So here's how you might actually do it with Ecto. You might check to see, hey, is there a named binding called friend link? And if there is, then don't join to the users. And same here, if there's a named binding called user, then don't join to users. Now you've optimized it, it's great, but it's complicated and kind of for no reason. And another thing that you get when you start building things like this is what I call accidental languages. So this is not, like there are semantics in these functions. So this friend link atom, it's not just a name you gave something, it's a name you're using in multiple places to refer to this optimization that you've made. It's an optimization language. And I actually believe I believe that you should be introducing languages to describe the things that you're doing, just not accidentally. And that's a very important distinction. So, closed to extensibility. This is the sort of thing that you get if you were to generate like a Phoenix context. But what if you want to add like analytics code, where like every time something happens with a user, you send off a data to your analytics platform, or you audit log it, or you something like that, right? Well, you have to add code to all three of those places. There's no other way to do it. Well, maybe you could go to your repo and you could modify your repo.delete to like check and see what you're deleting, and if it's a user, then do analytics code, but definitely don't do that. So this is, in a way, closed to extensibility. You have to modify a bunch of different places to extend some part of your domain. Single-use functions. So we've got this def full name here, right? Given some user, we're going to calculate their full name. However, we also have a need potentially to do this in SQL. Let's say we want to do like a filter, where they can go to a thing and they can type in a box and it'll filter by the user's full name. This is duplication. It's not duplication in terms of the same Elixir code duplicated, but that's the same concept, that the full name of a user is user.firstname plus a space plus user.lastname. Full names don't work that way in real life, but for this example, it will suffice. So we could do something. We could maybe extract out that bit, should be calling full name in that example, but we could extract out full name, and we could make it clear that this is that, right? So when you look at it, you're like, ah, okay, this is the user's full name. But you aren't actually combining the two concepts. You still have the classic problem that there's no one source of truth that is flexible enough to model both of these things, that the full name in Elixir and the full name in Postgres. So, limited composability. Let's go back to our example where we're joining, right? And let's say that we want to actually OR these two conditions together. So we want to write another query, a different thing, not front page, and we want to say where it's for active users or it's from my friends, right? Well, let's say we were to do that like this. We introduce an OR for friends of function, and in OR for friends of, we join friend links, and then we say OR where, right? So that's an ecto way to do this sort of thing. There's a problem with this function, and I'm curious if anybody can spot what the actual problem of this is going to be. It's not performance or anything like that. Anybody? So that's not, the problem is actually here, in join friend links. That's close, but the issue here is you're not, okay, or for friends of is not going to include any users that don't have any friends, because this is still doing an inner join to friend links. So your OR is not a true logical OR, right? It's introducing an additional constraint because of this. This is an instruction. Join friends link is not declarative. It's an instruction we gave it to inner join on friend links. So yeah, you have to left join, and now all of a sudden you have to make entirely new code paths to handle how you compose these things. If you want to say or this or that, you have a whole new code path that does everything differently. It does a left join and it does an or where, and at that point you don't have any reuse out of the things that you're actually building. So this is the kind of thing that we're trying to solve with Ash Framework. Let's go back to the examples, and I'm going to show you how we solve these specific things in Ash. So in Ash, we have a thing called calculations. And in calculations are declared in such a way that we know what order to run them in, and we can solve that, and we can solve the dependencies from one calculation to another. So when you want to load two computed fields, you just ask us to load both computed fields. And if some computed field 2 depends on some computed field 1, that happens. We do them in that order. And if they don't, we do them asynchronously together, potentially. It depends on the implementation. So order mattering is not a property of computing fields. It's just part of that initial implementation that was restrictive. Let's talk about simple or optimized. What about simple and optimized? So we talked about calculations, right? Let's refactor those concepts of, from, friends of, and that sort of thing to use calculation in Ash. So we have this for active user, and what this does is this filters, it's true if user.active equals true, right? So this is a truth statement now, and this is the sort of thing that actually does compose. And now we have from friend, which takes a user ID, and it is true if the user.friendlinks.friend ID equals that user ID that you gave us. Notice there's no join instructions there. There's no imperative instruction that says join to user.friendlinks. And that's because we do it for you. The underlying query builder decides to join, and it reduces the joins to the minimal subset of joins that must be made. So this will only join one time, even though we have two things that depend on the current user, on the related user. I thought there was another slide, but let's just jump right into the next one. So let's talk about this accidental language, right? You can see here that this is what I was mentioning, where friend link and user have meaning in this sort of optimization language. So let's instead use these sorts of calculations to design the language, right? Where this is a named thing that's fit for purpose. For active user is designed to be used in various places. Again, I thought there was another slide. So close to extensibility. So in a Phoenix context, when you have a bunch of functions, right? Functions are not the sort of thing that you can open up and extend. You have to add code in them to allow you to extend the function. So in Ash, we have actions, and actions are extensible by nature. So in a resource, you might have a list of actions, like create, update, and destroy. But you also have a place to put cross-cutting concerns. So these changes block down here, think of change as like a plug, but for a change set. So this plug is going to run on every on every action, which means that you can, if you have some cross-cutting concern that you need to introduce to your resource, you don't have to add it to every single action. Now, I think there's actually a good argument to be made for doing this sparingly. It is very helpful. If you only have 3 actions, right, it's very helpful to see in each action exactly what the action does. So I'm not suggesting that just because it happens in 3 separate actions means it belongs in this sort of placed elsewhere position. But the ability to do this is really important, because what it means is, let's say there's 3 actions and I'm adding this change to each one, and then I add a 4th and a 5th and a 6th and a 7th, and all of a sudden it's actually unclear. Now I can just move it to this area without changing anything about the implementation. So I, as a developer, get to decide where this thing goes. And that's a pretty powerful tool. So single-use functions, this also comes back to calculations. So we have portable components, right? So these expressions are portable expressions, which means we can evaluate them in any data layer that we support, of course, but any data layer or in Elixir, or a data layer that you decide to support. So in this example, we're saying filter where full name equals John Doe, right? And that gets run in SQL, right? It would be horrible if you read the whole table back and then filtered in Elixir. That's not acceptable. But we can also just calculate the full name, given values that we have here. So this single function, this calculation, is both. It's both the Elixir version and it's the SQL version. And because of that, because these portable components exist, we don't have to proliferate concepts into different implementations. So let's talk about this composability. How do I OR these together? So our calculations are composable by design. So in this, we have these 2 calculations here. I can say for active user and from friend, or I can say or from friend. And we know that we have to left join in the second case. We understand the way that works. So we can also compose them in ways that you would never even have thought of, which is we can say if for active users, then it should be from my friend. Otherwise, it should not be from my friend, right? And this will all get compiled down to the equivalent, to the necessary SQL, the equivalent SQL expression. We can also use these calculations in policies. So we can say, if this tweet is for an active user, then you're only allowed to see it if they're your friend. So these composable and portable calculations solve so many problems that we were talking about earlier. We can use them in our atomic update statements. So in this case, we can do, this will be an update or a create statement where this is compiled down to the SQL, and it'll say, if it's for an active user, then the status should be published, otherwise pending. And all of a sudden, we don't have to do application logic where we loop over things and decide what to make in the query, all that sort of stuff. We can leverage our domain, our nicely named domain concepts throughout our system. So I'm going to do a little bit of a dive into a specific thing as opposed to trying to give you like a wide overview of all sorts of things that Ash has. Ultimately, we have documentation. If you're interested, you'll go do that yourself. But I think it's cool to show what we've been working on and what I think is one of the more innovative parts of Ash. So let's talk about an update action. This update action has a change. We talked about this like a little plug for your change set, and it sets the attribute published to true. It's a really simple action. It doesn't take any input from the outside world. You just, hey, given a post or a tweet, you're going to publish it. And you might build a change set and then update it, right? This is you've seen this sort of thing with Ecto or many other paradigms, right? You define some operation and then you execute it. But what if you want to publish many posts? You have a query over posts and you want to publish each one of them. If you were using Ecto, for example, you would need to modify the logic to use like repo.updateAll, and you should have to rewrite it to give it like a query that can actually be executed. But in order to do what I just described, where you do update all, this has to be able to be turned into an expression, this set attribute published true. To see how that works, you're going to have to know what that is. Surprise, it's data, because everything in Ash is data. So this is just telling us about a module somewhere that is going to implement a behavior, and then some inputs to that module. And in that module, you can define change, which is like how to do this in Elixir land, how to do this with a change set, or you can define an atomic callback, which is how to do this in the data layer. So now we can just say, we can use the same action. Notice I don't have to change the action at all. I can just say ash.bulk update, give it a query, and you get this SQL query back, where it runs this SQL query for you. So we can take your domain operations that are expressed in the singular and run them in the plural without any change required from you. Validations can be atomic too. And it's actually important that if we're going to support atomics, and this is one of the benefits of Ash, is that we actually support atomic updates across all of the feature set, well, as much as we can. You can do things where it's going to say, hey, sorry, I can't do that atomically. But those things are rare. So in this example, we're saying, okay, we're going to update, this maybe a games resource, and we're going to update score and set it to score +1. But there's a rule that score is never allowed to be a greater than 100. And you get a SQL query like this, where we're going to do a single SQL query that makes the update that you want and confirms any invariants, like the rules of your action, which is very powerful. What about policies? So in Ash, not only do you have to honor validations and the rules of the action, but you also have to honor the rules about who can do what. Well, these are expressions, and we can put these in the database. We can put these in the database query. So now you can see we get a single query that simultaneously validates the rules of the action and the authorization rules of a user. And what you get out of this is that you can just say, update all of the games that I know about. This is implicit sort of, update the games and set their score +1. And that's safe to do, and it will happen in a single query. You don't have to do these like complex designed operations for every little thing that you want to do. Your actions are reusable. Increment score is a simple action, but it just works when I use it in bulk, and it will be done atomically, concurrently safe, all that sort of stuff. So we have a thing called Ash State Machine. In Ash State Machine, it lets you define the allowed transitions from one state to another state, and sort of, many of you may have seen this sort of thing with Ecto State Machine or Gen State M or all these sorts of things to basically build state machines, and we let you do that with Ash resources. But what about this? This is a change that it's not supposed to just move the state to pending. It has to be a valid transition, right? So it depends on the old state whether or not you're allowed to move to the new state. Well, I can just, and I did, implement the atomic callback in our transition state change, which this is a relatively complicated version of atomics. But the point here is that I can represent that same logic. I just write this one little thing, this composable atomic concept, which is basically like, look, if this next state is a valid state and there's a matching state transition, then you're good, set it to the target. Otherwise, we're gonna get an error, right? So this kind of thing is really powerful, and our users are seeing that, right? So this is one of our users that is using Ash State Machine, and they said, I'm just gonna read this. Thinking about this, it makes me realize that this is quite amazing. I would never have taken the time to make such an action atomic with just Ecto. I maybe would have locked somehow if it were very important, but now it's just a drop in, don't think about it feature. And I think that's actually really powerful, because if you need to work with state machines in a concurrency safe way, what you almost always end up doing is locking or using a mutex or some sort of resource sharing to allow you to do these things safely. But now that these operations are atomic, you just push the button. You don't have to worry about it. The end, or is it? So we actually have a big release coming up, and everyone's been asking when 3.0. So we actually do have a release date. But an important note before I tell you when, last year my wife baked me a cake for 2.0. This is still my most liked tweet to date. And this year she one-upped herself. So you might think you're going to see an Ash 3.0 cake, but no. This is Pippin. And Pippin is very excited about 3.0. So he's got his Ash 3.0 jersey. And I can't keep my best bud waiting. So let's just do this thing. You guys ready? All right. Yes. Oh gosh, I'm gonna have to type a password in. Oh no. Don't worry about it.
No one saw anything.
All right. Now, if you don't want to be in a picture, you should leave this splash zone right now because I'm going to take a picture of the room. All right, let's see. Okay, I'll tell you what. I'm going to do it like this and not get myself in it.
Here, I'll take it for you.
Yeah, all right, cool. So I'm about to tweet this. Speak now or forever hold your peace. All right.
I'll put it in the wide. Oh, you have it in wide. Awesome.
Yeah, all right, let's do it.
History. Say, kiss my ash.
Kiss my ass.
Awesome.
All right, thank you.
Absolutely.
All right. So we're gonna do this live too, for what it's worth. I'm gonna tweet this right now. I'm gonna airdrop myself this photo. If it tells me where it went. Here we go. Boom. And post it to Elixir forum also. Let's go. Why not, right? Oh no, it's not authorized. What's wrong with it? Okay. It is. Okay, I'll do that one later. But thanks all for being here for the 3.0 release. Yeah, I got a lot more packages to release.